In May of 2026, engineers at NASA's Jet Propulsion Laboratory noticed something in Voyager 1's telemetry that genuinely didn't add up. A specific onboard system, the one responsible for keeping the spacecraft's antenna pointed at Earth across a distance of more than 15 billion miles, was reporting numbers that simply didn't match what the spacecraft was actually doing. Everything else was working fine. The antenna was pointed correctly, commands were being received and executed. But one particular stream of data coming back to Earth looked, in the words of engineers who've spent decades working on this mission, almost impossible. Stick around, because I'm going to walk you through exactly what NASA found buried in Voyager 1's data, why a nearly 50-year-old spacecraft is still capable of genuinely surprising the people who built it, and why this isn't even the only unexplained anomaly currently sitting in the spacecraft's data. And if you want more of these deep dives into real published research instead of recycled headlines, go ahead and subscribe now, because there's a lot more coming out of the edge of our solar system. To understand why this particular glitch is worth taking seriously, you first need to understand what the system in question actually does and why it matters so much for a spacecraft this far from home. Voyager 1 relies on something called the Attitude Articulation and Control System, abbreviated AACS, to keep its antenna precisely aimed back at Earth at all times. That precision is essential. Voyager 1's transmitter puts out only about 22 watts of power, roughly comparable to a refrigerator light bulb. And by the time that signal crosses the more than 15 billion miles separating the spacecraft from Earth, it is spread out and weakened dramatically. Even a small misalignment in the antenna's pointing could mean the difference between a signal NASA's Deep Space Network can still detect, and one that simply disappears into background noise. The AACS is what makes sure that never happens, constantly monitoring and adjusting the spacecraft's orientation to keep that narrow beam of radio signal aimed precisely at a planet the spacecraft hasn't seen in nearly 50 years. In the spring of 2026, engineers monitoring Voyager 1's telemetry noticed that the data coming back from the AACS didn't appear to reflect what the spacecraft was actually doing. According to NASA's own account of the anomaly, the system appeared to be relaying essentially garbled, effectively random data that didn't correspond to any real physical state the spacecraft could plausibly be in. And yet, despite that garbled reporting, every other indication suggested the spacecraft's antenna genuinely was still pointed correctly at Earth, since Voyager continued receiving commands and transmitting usable data the entire time. Suzanne Dodd, the project manager for both Voyager missions at NASA's Jet Propulsion Laboratory, addressed the situation candidly, noting that a mystery like this is essentially par for the course at this stage in the Voyager mission's life, given that both spacecraft are now operating decades beyond anything their original mission planners ever anticipated. If you're finding this as puzzling as the engineers clearly did, drop a comment and let me know, because it genuinely helps me figure out what other space stories are worth covering next. That specific contradiction, a system reporting effectively meaningless data while the actual underlying hardware continued functioning correctly, points toward one of the genuine hazards of operating any spacecraft this old. After nearly 50 continuous years of operation, individual components inside Voyager 1's computer systems have been exposed to a level of accumulated wear, radiation damage, and general hardware fatigue that no engineer designing the original systems in the 1970s could have realistically planned for. This wasn't actually the first time a problem like this had cropped up either. Voyager 1 experienced a broadly similar issue back in November of 2023, when a different onboard computer began transmitting a repeating pattern of ones and zeros that carried no usable information at all, a problem engineers eventually traced back to a single corrupted memory chip. That earlier fix required splitting the affected code into separate pieces and storing them in different working sections of the computer's limited remaining memory. A genuinely clever workaround that ultimately restored the spacecraft to full, usable data transmission by the following spring. This more recent AACS anomaly adds to a broader ongoing pattern of Voyager 1, requiring increasingly delicate, hands-on troubleshooting, simply to keep functioning at all, precisely because the spacecraft's dwindling power supply leaves almost no margin for error. Both Voyager probes run on radioisotope thermoelectric generators, devices that convert heat from the natural radioactive decay of plutonium into usable electricity, a power source that has been losing roughly 4 watts of available output every single year since launch, with absolutely no way to replenish or recharge it. That steady decline forced a particularly consequential decision earlier in 2026. During a routine, scheduled roll maneuver on February 27th, the kind of maintenance procedure the spacecraft periodically performs to calibrate its magnetometer instrument, engineers noticed Voyager 1's power levels drop unexpectedly, concerned that any further decline could trigger the spacecraft's built-in undervoltage fault protection system, a safeguard that would automatically begin shutting down additional systems on its own to prevent a complete power failure. Engineers made the deliberate decision on April 17th to command the shutdown of Voyager 1's low-energy charged particle instrument, an experiment that had been continuously operational for nearly 50 years. That sacrifice was made specifically to buy time for a considerably more ambitious plan currently in development, an upgrade the mission team has nicknamed the Big Bang. According to reporting on the plan, engineers are working on a bold reconfiguration of the spacecraft's remaining power budget that could not only extend Voyager 1's operational life further, but potentially even allow some of its previously shut down instruments to be revived and brought back online. As of August 2026, only 2 active science instruments remain running aboard Voyager 1. The magnetometer and the plasma wave subsystem, the same instrument responsible for detecting the interstellar plasma hum discovered back in 2021. It's worth being clear and direct about what all of this actually means, since a headline promising something unexpected in Voyager's data could easily be read as suggesting something exotic or alarming. The AACS anomaly, as best understood by the engineers actually working the problem, reflects the ordinary, if genuinely difficult, reality of operating irreplaceable 1970s-era hardware for nearly 5 decades in one of the harshest environments imaginable, rather than any indication of something mysterious happening in the space surrounding the spacecraft itself. Dodd's own framing captures that distinction well, treating this kind of glitch as an expected, if still challenging, consequence of the mission's extraordinary age, rather than evidence of anything unexplained about interstellar space itself. That said, there is a genuinely separate, considerably more scientifically interesting mystery buried in Voyager 1's older archived data that remains authentically unresolved, and it's worth explaining clearly because it's easy to conflate with hardware glitches like the AACS issue. Voyager 1 carries an ultraviolet spectrometer that, between 2003 and 2014, recorded something researchers still can't fully explain using existing models of the heliosphere. The instrument was measuring a specific kind of ultraviolet light called Lyman-alpha emission, produced by hydrogen atoms, across the region roughly 90 to 130 astronomical units from the Sun. Standard models predicted that emission should have varied in a specific, predictable way as Voyager traveled through that region. Instead, published analysis of the data found a surprising flat period between about 90 and 115 astronomical units, where the intensity stayed almost constant in a pattern existing heliospheric models simply couldn't reproduce or explain. Researchers proposed 2 possible explanations, either an unexpected dense layer of hydrogen sitting near the heliopause that current models don't account for, or some additional source of ultraviolet emission originating from beyond the heliosphere entirely, possibly a broader galactic or even extragalactic background glow. Neither explanation has been definitively confirmed, and the paper's own authors were explicit that further investigation is still needed to properly resolve exactly what's producing that unexpected excess. That's a genuinely open, scientifically legitimate anomaly, quite different in character from an aging computer system reporting corrupted telemetry. It's also worth being direct about something else, since search results on this general topic turn up more than a little exaggerated content. A number of lower quality websites have published sensationalized claims suggesting Voyager's various anomalies point toward evidence of alien technology or information NASA is supposedly concealing. There's no credible basis for that framing in any of the actual peer-reviewed research or official NASA statements about either the AACS glitch or the Lyman-alpha mystery. The real story, hardware pushed nearly 50 years past its expected lifespan, combined with a handful of genuinely unresolved physics questions about the exact composition of the heliosphere's outer boundary, doesn't need embellishment to be worth paying attention to. It's worth appreciating just how remarkable it is that a spacecraft this old remains capable of producing this many genuinely open questions at once, spanning both engineering and pure astrophysics. Voyager 1 is currently more than 16 billion miles from Earth, with a radio signal now taking in excess of 24 hours to complete the one-way trip, and it's expected to cross the milestone of 1 full light day of distance from Earth sometime in November of 2026. Every additional month, this spacecraft continues operating, despite a computer system reporting corrupted data, despite instruments being deliberately shut down to conserve dwindling power, and despite a still unexplained gap in one of its oldest datasets, represents genuinely borrowed scientific time, extracted from hardware that has already outlived every original projection for how long this mission was ever supposed to last. So, what does all of this actually add up to? NASA really did find something unexpected in Voyager 1's data this year, a computer system reporting numbers that simply don't match reality, even while the rest of the spacecraft continued functioning normally. The honest explanation is a genuinely difficult, ongoing engineering challenge rather than anything exotic, the natural consequence of operating 50-year-old hardware at the absolute edge of its physical limits. Layered underneath that immediate engineering puzzle sits a separate, older, and considerably more scientifically substantive mystery, an unexplained excess of ultraviolet light recorded in the outer heliosphere that researchers still haven't fully resolved more than a decade after the data was first collected. If stories like this one, grounded in real published research and honest about which mysteries are genuine and which are exaggerated, are what you want more of, subscribe to this channel and turn on notifications, because engineers are still working on that Big Bang power upgrade. And there's a real chance the next update on Voyager 1's condition brings either good news about its survival or another piece to an already growing list of open questions. Thanks for watching, and I'll see you in the next one.